Hi, everyone. Just let me know in the chat window if you can hear me okay. Okay, great. We're going to get started. Just give maybe a minute more for people to arrive, and then we're going to get started. The topic for today is we're going to talk about building your career in the EV industry. So we'll just give it about a minute more, and then we'll start with the presentation. Okay, great. So thanks so much for being here. I'm Akshay. Some of you have seen me before. I believe there are some previous course students here as well. So welcome to the webinar. Today we're going to be, hi Sujai, hi Nagendra, hi Amrik. Thanks so much hi Riaz. Thanks so much for introducing yourselves in the chat window. Yeah, so today's topic, we're going to talk about building your career in the EV space. So it's going to be maybe 20 minutes, and then I'll take up a few questions on the chat window itself. And so yeah, so let's get started with that. So I'm Akshay. I've been in the EV space since 2008, and I have worked previously in a lot of interesting projects. Before Makermax, I was working at Tesla Motors in their battery R&D department in California, and I'm currently the director at Makermax. I'll introduce the company to you. So at Makermax, we're making some of the things you see on your screen right now. So our focus is core EV technology, and in that we have also a core focus on battery technology. So the red board that you see on the screen is our pack analyzer. On the right, you see cell analyzers. And on the bottom side of the screen, you see educational shields that some of you have already worked with that we build to help you upskill in this industry. So on the agenda for today, we have how to build your career in the EV space, right? And in that, we are focusing on 4 different areas, which are all very interrelated, but talking about if you are coming from the ICE automobile field and you're going to the electric vehicle field, or you are a new graduate who wants to get an opportunity in the EV field, or you're already in the EV field, but you want to improve the quality of the work that you're working on. And lastly, if you're starting a business in the EV field. So that's the agenda for today, and the presentation will be about 15 minutes. So not everything is has to be started from scratch, right? So we're still building automobiles. There are a lot of areas that are still being used from the industry that we had before, which some of that are braking systems, suspension systems, and steering columns. So those kind of things, if you are working on and if you focus on mechanically, then you should still continue to improve in those areas, as there will still be useful for the EV industry. And there will be transferable skills from that into the new component equipment industry that will develop because of the advent of electric vehicles. In this presentation, though, I'm going to talk about the upscaling, the need for upscaling from the ICE automobile to the electric vehicle automobile. And in the ICE automobile, there was a heavy focus on the mechanical aspects of things, whereas in the electric vehicle, as the name suggests, it's a focus on electrical engineering, it's a focus on software engineering and power electronics. So some of the sub fields that are taking prominence or main stage now are power electronics, embedded systems, precision electronics, and connectivity. And I'll talk about how each of these areas are being used in the electric vehicles. For example, power electronics, right? So in charging, if you're going to be designing charging systems, or if you're going to be designing power conversion systems that will convert, say, a 400-volt battery pack to a lower voltage 12 volts or lower voltage needed for the ECUs to run. That is all handshaking of power, conversion of voltages. That all comes into the domain of power electronics, right? And then embedded systems comes more on the side of how do we sense different things on for the ECUs. For example, a battery management system has to properly sense voltage, current, temperature of the cells that are connected to it, and and also for developing the algorithms that will govern the safety and the performance of those cells. That realm of ECU management comes under the topic of embedded systems. In precision electronics, it's about designing things like filters. So you have low voltage components and you have or circuitry, and you have high voltage circuitry working in tandem to make the electric vehicle work. And a lot of times you'll see when you're implementing low voltage electronics on your desk, you'll find that some of the things like noise don't creep in to that subsystem. But when that same subsystem is installed in an electric vehicle, the high voltage components like the motor generate a lot of noise, 20 kilohertz, those kinds of frequency noise, that then enter into your low voltage circuits and then inhibit the working of those. So those design of filters and design of that noise immunity in circuits comes under precision electronics. And connectivity has a few different roles in electric vehicles. So we are looking at a lot of companies that are putting out hardware, like Tesla is one of the main examples of, they put out the car and the software iterates over time. So that for that, you need connectivity. You need the vehicles to be connected to a central server. So that is one way in which connectivity is being used. And in second, the algorithms, for example, even the battery algorithms, there's a lot of use of big data and artificial intelligence in algorithms these days, where it's no longer a case of for loops and if loops. Those form the basis of the algorithms, but it's about how do we use the data that we're collecting from a lot of vehicles and from our labs, how do we put those all together and figure out or predict how things are going to happen for that specific vehicle or for a fleet of vehicles in the future. So that prediction, those kinds of pattern matching things also don't fall into connectivity, but have a need for connectivity for those things to work. So two of these areas in connectivity, but in general, these are the four main areas that are gaining a lot of prominence in electric vehicles. Now, how do we get better at this? So electric vehicles, as you must have noticed already, is very technologically heavy, right? So, and for that, any new technology that we're going to learn has to happen through experience and through a hands-on learning way. And this is what I encourage all the time in my in the talks I give on YouTube, or the talks I give physically, or even in my courses, that we have to learn from a hands-on a way to develop that intuition. Because a lot of times I've done myself things in college or university or read in a textbook that were no longer relevant when I was actually trying to solve problems in the field. At that time, the way to relate is, hey, I worked on this project at that point in time, and this is how I solved it there, and this is the problem I'm having now, so this is how I'm going to solve it. So develop this. Reading material is not enough. You have to start working with things in order to gain that intuitive knowledge, right? So one way, which I call the hard way of doing it, is investing hundreds and thousands of dollars in sophisticated lab equipment and forming a lab around you. Like, this is a popular YouTuber called Carlson's Lab, and I'm not trying to say that his lab is too much or anything, but I'm saying it's hard. It takes a while. It takes a lot of resources to get all this equipment together. But so what's the easier way, right? So the next way, or the better way, is to work with smaller equipment. Some of these we make, and some of this is also in the industry, where you can work with smaller equipment, and like what you see on the screen is the DC-DC board, the ion board, the SC4PO board. These are all meant to condense all that learning into kind of handheld devices where you're able to run those experiments and learn that intuition, which is very important to develop. right? So the kind of takeaway from these slides so far is that please focus on developing hands-on, and the way to do it is through projects. There are some things that need to be reimagined, and this is an example of the Model 3 dashboard, which you see is very different. And even if you looked at um, the Cybertruck reveal recently, it's a lot of things are being reimagined, right? So it's breaking the trends of the industry. So one of the things you see on the screen is on the slide is there are barely any buttons on the screen on the dashboard. And the reason for that is because technology is changing very fast, right? So you don't want a physical button to control a feature when you can have a touchscreen button on a display that can be changed with connected software later as you want. And second, you can see that there are no vents. So a lot of the thermal or just air conditioning and those kinds of things are also being rethought of or reimagined. So there's opportunities in those areas as well to rethink things that we've been doing for the past 20, 30 years. And should those be done the same way, or are there better ways of doing it? And all of these have a focus on embedded systems, control systems, power electronics. Those kinds of things are all playing into, and a lot of huge focus on advanced software that is going into the vehicles these days. Some of the general advice I have before we get into specific advice is that I mentioned this before as well, that books are meant to be reference material, especially in a technologically advanced or very fast changing field like this one. If you're using books as your primary resource, then it's kind of developing, the knowledge that you develops also goes away really fast. So you need to retain that knowledge, and for that you need to work on projects. Clarity of fundamentals has been so important in my journey as well, where sometimes I don't know the answers to complex problems, but if the fundamentals are clear, then solving the complex problems becomes easier because you can break down those problems into their fundamental aspects. And even when things like field issues come about, if this sensor is not working or that board is not working, when we are sitting even here as a team and solving those problems, we look at, okay, what are the main things, the fundamental things that can go wrong? And from there, we kind of then look at how that problem might have occurred. So the fundamental analysis, or we call the first principle analysis, is very important. And for that, again, the development of that will happen through working on projects with your hands. So the third point I think is pretty clear already. I'm going to jump to the last one, where self-studying and self-study it doesn't end at university, or if you're a college grad, a lot of the attendees today are recent graduates from college. And so it's not that once you have your degree, the learning has stopped. Even once you are in the field and you're working every day, you have to keep on the side working through problems and through projects and experiments to improve your understanding of the material. And that's for everyone. And because the fact is because the technology is changing really, really fast. Now we'll go through a few examples based on the questions I receive most often, and the first one is, I recently graduated from college. How do I gather the relevant experience without the right opportunity? It's kind of a chicken egg problem here that I see happening a lot, where students say, I need an opportunity to be able to develop the skills, whereas companies are looking for students or graduates or even employees with already some skills that are built. So here, my recommendation is 3 different areas. The first of it is participate in contests. We run some contests as well at Makermax. There's one currently running on our forums where you can, it just becomes exciting to work on those projects, and also a chance for you to showcase what you know on a larger stage. So these contests are happening in different places. If you can connect with me later, I can definitely share some links with you. And these are great opportunities for college grads to showcase their work and their learning and highlight them on a larger stage. The second is you have a very, very good resource of university labs. And those kinds of labs, once you're out of university, take a lot of investment to set up. So if you are closely tied to a university, definitely do those experiments. Use the equipment that's available in the labs to run those experiments, um, and gain that intuition, right? So I find myself almost 2-3 hours a day in front of lab equipment working on different types of experiments with lithium-ion batteries. So yeah, the thing is, once you're out of that college setting or that university setting, having that lab set up becomes more and more challenging. It takes a lot more investment. Self-study is something I touched on before, is always keep growing yourself through courses, um, through working on group projects to try to improve your resume and your experience. And a lot of companies want, it's funny when you go into a company, even the top companies, some of the top companies in the world in EVs that I've worked in, from the outside, it looks like it's so hard to get into companies like that. From the inside, there's actually a very high need for skilled people who can help generate that next iteration of technological problem, or help solve those technological problems. So it's strange for me how on the outside there's so much need, and also on the inside, but there's no match. And because is it comes down to the students wanting the companies to teach them, and the companies wanting the students to have some basic knowledge before they enter. So focus on developing that basic knowledge on your own. The second is the ICE veteran. A lot of times I get approached people asking, hey, I have experience, like 20 years, 30 years of experience in the ICE industry. I'm worried I won't have my job 5 years from now. What can I do to develop the skills in EV? And some of this comes back to the transferable skills I was talking about before, where not everything you know already is, you have to throw it in the garbage, right? A lot of what you know and the experience that you've gathered, especially in things like manufacturing, is going to be super important in getting EVs out in huge numbers in the field. I remember at Tesla, when the push for Model 3 was happening, there was a huge focus on switching all the efforts to manufacturing and how we can accelerate manufacturing and get those numbers. So at that point, there was a huge demand for people who have manufactured, thousands of vehicles and pushed those kinds of numbers in the past. So even on the design side, mechanical side, and manufacturing side, there are a lot of transferable skills that you should not throw away. You should still still keep improving on those. Having clear fundamentals will get you the right opportunities. It's not about, hey, I know how to design this battery management system from start to finish. It's about when a problem comes in and you're trying to solve it as a team, are your baselines clear? Does resistance of a lithium-ion cell, does it change or does it go up or down with temperature? What happens? What are things like voltage polarization in lithium-ion cells? These kinds of fundamental understanding of the subcomponents that you're working with. If you have a very clear understanding of those, you can work with more complex problems a lot easier. So the focus should be to develop that fundamental understanding. And the other thing is that college projects, where student teams work on a project like the SAE car, these types of things, these are very useful. Even Formula Electric competitions are gaining quite significance, quite a lot of significance these days. So mentoring these kind of college projects can really help you also develop the right skill set. And lastly, I want to talk about, if you are starting a business venture or you already have started a business venture, how do you go about that? I'm hearing a lot of buzz in the industry. How do I get started with my venture? I don't know where to get started. Do I have the right skill set for it? So one of the things I see happen a lot is people running after, oh, other shared mobility company got these many dollars, $1 million of investment, I got to get into it too. By the time you get into it and you actually develop, the infrastructure needed to have that, it might already be too late. So don't run after the investments, run after developing a core competency or a niche in the industry, because there's a huge need. Everyone keeps focusing on the same things, I find. There's a huge need in all, it's a full ecosystem that we have to develop in order to see electric vehicles on the roads in huge numbers. And for that ecosystem to develop, all of us have to choose these different areas based on our interests and based on our skills. So look at charging systems, look at even financing services, look at setting up servers for like huge amount of servers for connectivity solutions, or provide different types of connectivity solutions for EVs. Or something like, for example, we have chosen to focus on analysis of lithium-ion cells of different subcomponents inside electric vehicles, and we have focused on the education side of the EV ecosystem. So a lot of different opportunities exist that are needed in the industry to make it go forward. And the point that is true to all of the above is self-learning shouldn't end, and it has to happen in this case not through books, but it has to happen through iteration. And having a team or having a group around you who thinks in the same way, or who are experimenting in different areas, is also very useful. So that when you are focusing on, say, a battery technology aspect, and someone else is focusing on motor controls or DC-DCs, those kinds of things, there is a shared learning that can be achieved here as a group. So yeah, those are a few of the examples. In terms of what companies are looking for, like I was saying, there's a huge need in the industry in the EV space. And from what I've seen and what I see when we are hiring as well, is you have to stand out from the crowd, right? So you have to have a way of showcasing to the company, which is in need for the right skill set. How do you showcase that you have that skill set, right? So you have to think a little differently. For example, I'm showing you a picture of a simple project that was set up that shows a basic understanding of how power flow is happening between different subcomponents of EVs. This is something we do in the foundations course. And even showing that how you can control speed of the motor and how current is flowing through auxiliary loads, what happens when auxiliary loads are connected and the motor is connected simultaneously, how does noise propagate from motors to the different subcomponents. These kinds of understandings, if you have, are very, very relevant to the industry. And to stand out, one of the things we do with the graduates of our courses, and you should start doing as well, is that we build a, you barely have, when you're looking at a resume or you're looking at from a company's perspective and you're looking at hiring someone, you barely have 15 seconds, 20 seconds to form an impression on the hiring person. And for that, you have to very specifically showcase your skills. For example, on the right is something we build. We give a special URL for all of our graduates of our courses. And in that we showcase, okay, this person is experienced in such technologies. They have these certifications, they've worked and these kinds of things, they have done these projects, and here are the references. So right away, I'm interested in the person, I have an opportunity in component level testing, this seems like the right person to hire, and you have people backing that person as well, saying, hey, I have worked with this person in the past. And so that in that 15 seconds, it's giving me a full picture, not a complete picture, but enough picture to form an interest in taking the conversation forward with that person, right? So this is something you should definitely do for your applications as well. I'd just like to end with a few of the upcoming courses, and I'm happy to take some questions after this. We have 2 courses on the EV Foundations and the BMS Masterclass, very popular courses that we run. I'll leave this information on the screen. They're starting on December 5th and 15th, respectively. And those are the links for both of them. And this is my contact information. I'd be happy to take emails or send me a WhatsApp. And I'm happy to take like specific scenarios and some things that you're working through, the problems that you're having currently, more specifically over these two. So I'm going to leave that contact information on the screen. And if you have any questions, you can send that to me. I'm happy to take 1 or 2 questions on chat and follow up with more questions on email or WhatsApp. So thanks so much for watching, and I'll be around for a few more minutes if you have any questions. So Vikash is saying, yeah, India is a very big market for electric vehicles. That is correct. We are seeing a lot of development in EVs. I recently gave a talk at Economic Times event in New Delhi, where I talked on battery safety. So that's a very growing topic that I found in that talk, and also end of life, how to take care of end of life of cells was another kind of key topic that came out of that conversation. When I say everyone trying to solve the same problems, I'm saying like you have to think about the EV as an ecosystem, right? It's not just about building. Everyone has a focus on battery management systems, right? So everyone's trying to build a better and better battery management system. But what I'm trying to say is even thinking about the next technologies on how we can bring the cost down for connecting a charging station to another charging station, or connecting the charging station to a central server, something like that, or figuring out how we can bring the running cost of a shared mobility solution lower. Those are some things that are, or even like things like education of EVs, different areas of education of electric vehicles. So the ecosystem it's a large ecosystem that exists for EVs. And what I mean by attacking the same problem is because I see a lot of startups going after the funding. So when they see in the news that, oh, like X amount of $1 million were put into shared mobility, let's all run towards shared mobility, or X amount of dollars were going towards the next greatest BMS solution. Now let's start all developing BMS solutions. That's what I'm trying to say is the wrong way to think about it. Yeah, so Dhruv, I get your question on mechanical engineer. Mechanical engineer, I get this question a lot on, I'm coming from the mechanical stream. How do I develop the skills for an electric vehicle? Very good question. So you have to start iterating and learning. So the things you learn on the mechanical side will play a lot of a role in the mechatronics types of problems that you will solve in EVs. But you have to start to put some amount of energy in basic level coding and in developing simple circuits to start with, right? I'll give you an example. If you think today that I want to make a circuit, LED based circuit that can detect the charging level of a lithium-ion cell. So if you think about this type of a circuit and start to work on it, you will start developing some understanding of the electrical and the software aspects that will gain more and more prominence over the coming years in EVs. This will set you apart even as a mechanical engineer from the crowd. So it's great that you have the skill sets in mechanical, but start to put some energy also into self-studying about the electrical and the software aspects of EVs. Harsh wants to know about chemistries better than lithium ion. So, Harsh, what I have to say about that is that lithium ion has taken, the past 20 years or more to get to a stage where it is now starting to become more affordable for these kinds of electric vehicle types of applications for on a commercial scale. If you are looking, which majority of the people are looking from an industrial standpoint, at that point, I say that working on newer technologies like sulfur-based or different types of anodes or um, different types of additives for the electrolytes, those are works that are going on in research departments. So those are some of the efforts that are being done through universities or for example, Jeff Dan in Nova Scotia, Canada, runs a battery lab that do these kinds of things. But you have to think about that the problem that you're attacking there. You're looking at a solution that is a few years, 5 years, 10 years down the road. Um, currently, what the industry needs is how do we use lithium ion in different ways? How do we address the problems of having different types of mobility using lithium ion chemistry? So that is the larger problem to solve. But I don't want to discount the problem of research. If you are interested in going into research, there are a lot of labs that do look at other sorts of chemistries other than lithium ion as well. Yeah, so Shreyas was talking about supercapacitors. So ultracaps are um, have been being we've been researching those for the past 5 years or more now. So what it comes down to for ultracaps, or even there are two types of batteries that exist in the market today. There's an energy type cell and a power type cell. Some of the BMW cars, i8 and i3s, use this split pack type of type a split battery pack, where some of the cells are energy oriented, some of them are pack oriented. And this is where supercapacitors come in, because they can put through a lot of power output in a short amount of time, right? So it helps in things like heat generation. So if you try to take a lot of current out of lithium ion cells in a short amount of time, they will generate heat. So for these kinds of short, huge torque requirements, if you have in your application, that's where supercapacitors start gaining more importance. But in normal applications where you have average current requirements and not a huge amount of current burst that is needed for your application, then just lithium ion batteries are sufficient. Yeah, so Anvin is asking about swappable batteries. So so one of the things I want you to research on is this startup called Better Place. I don't know if you have heard about that or not yet. But Better Place was trying to do this many, many years ago on having a battery swapping station, and they had huge amount of investment in this area. But that startup failed. But I'm not trying to say that because that failed, swappable batteries are not a good solution. They're a good solution for a specific purpose. And that purpose is mostly on the commercial side. If you are running a shared mobility fleet and you have uh, 10 vehicles, for example, that have to iterate again and again throughout the day. So in that kind of a case, fast charging becomes inhibiting for that type of application. So in that type of application, if you have a swappable battery arrangement, then it's very useful for swapping. Yeah, so Sun Mobility is a startup that is Better Place is BETTERPLACE, Better Place. Yeah, so Sun Mobility is doing a lot of good work on swapping in India. So my view on that is it's going to be very, very useful going forward in fields like the commercial fields and the shared mobility type of fields. Hi, Riaz. Yeah, it's a very good question. Yeah, so about battery cooling, battery heating, a very interesting topic. So if your cells are below 0 degrees Celsius, and if you try to extract a lot of power out of those cells at that point in time, then at that point in time, the internal resistance of the cell is higher at those low temperatures. So you want to, for example, this even happens in Tesla cars, that the current output at lower temperatures or sub-zero temperatures are limited. So even though you throttle the accelerator, you push it fully, the amount of current that the battery management system lets you take out of the cells at that point in time is limited, until the IR heating, the heating of the cells because of the current draw, heats up the cell temperature to above 0 degree. Even I'm not talking about the environmental, and the environmental temperature might still be sub-zero, but the cell temperature, when it does become above zero and starts getting into 5-10 degrees, then we can start to extract more current out of cells. So it's a very important point that you bring up. Everyone kind of talks about cooling the cells, how to put thermal management in place to cool the cells, but it is also very important to know that in sub-zero temperatures or in very cold temperatures, it is also important to heat up the cells. Okay, so it's about 10, yeah. So I'd be happy to take more questions on email or WhatsApp, or connect with us on our website, and I can take some. Also, a good resource for all these questions, very interesting questions coming in, is our forums. If you go to makermax.ca/forum, I'm just going to type that here. This is a great place to start discussing in more detail, and we'd be happy to take more of these questions there. But thanks so much for attending, and I'm going to end the live webinar here. But yeah, I'd be happy to discuss further going forward. Thanks so much, everyone.